Hi, so this is Chirag, and in this video I will demonstrate how I will run the inference using the YOLO model and convert the YOLO models to the Onyx, and then again run the inference using the converted Onyx. So also I will use the AI tool for this task, and how I will actually perform the task from scratch. So first of all, I go through the requirements and understand like what actually we have to perform, and then I have converted one requirements markdown file, because markdown file will good to give context to the AI to perform the task very accurately. And here is the input image that we have to use for the task. So now I am providing this context to the AI, and this is cursor AI tool, and I am using the sonnet model, and I will use the plan mode because first of all we have to understand like how we will achieve this goal using the step-by-step execution flow and all required steps. So that will be good to understand before we creating anything. And now I am providing the model context to our cursor AI, and now I am prompting it perform the task from the requirement MD that I have created, and run the Python virtual environment using VNV. So now I am hitting this simple prompt, and the AI will get the all context of this image, this model, and the requirements. So in this requirement MD, I have mentioned all the things like what we have to perform exactly. So based on that, it will generate one plan like how we can achieve this. So I'm starting it. So first it thinking right now, and it will generate one plan. So based on that we will evaluate the flow, like is there anything wrong thing that AI has included in the plan. So we will change that, and then we run the plan, and we will achieve our goal. So now AI is starting the plan implementations. So let's wait for to complete it. First of all, it's created the folder structure plan, like this structure we will use, and here is the workflow diagram, like what we will do. So the plan is currently creating, so wait for it, and then we will review this plan. So now AI is generating the plan successfully. Okay, so first we check the folder structures, so like where our virtual environment will be there, our requirements.txt for installing the dependencies, and the script, like the script files to test our task, and the output where we get our results, and our model. And this is the workflow diagram, so we can check this, like from start, phase 1 we have to set up the environment, and phase 2 is PyTorch inference. So from this we will create one YOLO model in inference, so which will inference the reference image, and it will provide one result, and then we will convert that YOLO model PyTorch into the Onyx, and then we will again run that and get one Onyx result. And then the lastly we will comparison both model results using the IOU, so it will help to visualize the result and comparison properly. So now we will close this and go to the phase 1. So here AI mention all the things like what our goal, how we will perform all the things, and what actually we have to perform. So here is all the phases are mentioned. Now if we start with the build, it will execute this plan, and if we want any changes, we can perform here, and we can add new to dos. Like if you want to add something extra things, like we have to use some specific library or some specific task, then we can mention here from the new to do. And this is the agent to reference this task. So now I am starting the build, so it will execute our plan. As I see, the plan is very clear. So now it is thinking and started implementation. So now first AI has created the requirements txt. So in this AI mentioned the libraries that we have to use, and this is are the dependencies that we will use in the Python, and it is creating some directories that we will use. So here, and we have now results right now, and this is the script. So it is creating the script. So meanwhile we can check PyTorch inference. So in this it is using the YOLO model, and in inference the given input image. So these are the logic, and these are the steps, like what happens actually. It get the path of the image, then load the model, and run the inference and get the predictions. So all the steps are mentioned and all are the perfect. So in the final it will save the image to our output path. And on the convert to Onyx, so this is the second step. Like once we will inference the YOLO model, and then we will convert that YOLO models to the Onyx. So this is the logic, like we will get the YOLO models path, and then load the PyTorch model and export the Onyx and validate the Onyx model, and then the final steps. So this is a script for conversion to YOLO to Onyx. And side by side it is also performing all the tasks one by one. So now we will go to the Onyx interface. So this is the third step, like it is for the Onyx model to perform the inference for the input image. So here is the same thing as we have in the YOLO model, but in a different way. So it will do some kind of the class names and all the things to detect the object. And here is the same thing, like the path, load model, and the input details from the image, and convert to the required outputs and run the interfere. So these all are things same to the YOLO, but in a different way from the Onyx. So that's all the things. And the last is compare models. So at last we will compare the both model results. So this is a script from both. So the calculation of the intersections, and we will using the IOU to compare the both results from the both models. So these are the perfect steps. Is the distributions, confidence comparison, all the things are good. So now we can keep all the changes, and so first we have to start the environment from scratch. So we are going in the Unix, we are also in the directory. So now we can run this command to start the virtual environments, and we have to activate this. And now the virtual environment is activated. We will install the pip, and now we will install the required dependencies that we have mentioned in this requirement txt. So the phase 1 is completed, and provide the commands for phase 2. So we will go to the plan and see like what is the phase 2. Phase 2 is the PyTorch interface. So we have one command, so we can run this. We can perform the YOLO model inference. So this script is for that, and I will start the script. So script is running. Wait for the result. Meanwhile we check other things. So now the result is done, and we got one PyTorch result, and here is the actual terminal output, like what happens, like detected one object with the class name giraffe and confidence score and all the things. So we can visualize this using the IOU. So here is the image. So here is the confidence score and the objects and the name of the object like giraffe, car and person, and these are the confidence score from the PyTorch. So we have used the YOLO model, and now we will run the uh, we will convert the YOLO models to the Onyx. So we have to run this script. So now the conversation is running, and the phase 3 is completed, and we have converted our YOLO models to the Onyx, and now we will perform the phase 4, like we have to run the same inference using the Onyx. So now we run it again, and now the result is done. So we got one Onyx result. So look, this is the PyTorch YOLO model, and this is the Onyx result. Okay, so now the last step that we will comparison between the two models result. So for that we have to run this script, and it will compare and create one chart or maybe an image. Okay, so it is created one chart. Okay, so let me show that. So this is the PyTorch model prediction, and this is the Onyx. So for the IOE for each match detections, and the confidence score comparison. So here we can see this difference between this PyTorch and the Onyx. Blue one is PyTorch YOLO model, and the yellow one is Onyx. And this is the basic details regarding the average, minimum and the maximum statistics. So the average confidence difference between both models are just very less, and this is the difference by the class means maybe a object like giraffe in the car, and the total detection is 5. So these are the results. So thank you for watching, and the task is done.